Good morning to you once again. Last time we ended when we are going to be looking at the area measurement on the maps. Here usually we look at what we call the irregular objects and irregular objects. So when we are measuring the area, actually we find out that we shall be looking at what we call the irregular areas maybe occupied by population, vegetation, or different water bodies or swamps. Those are some of the irregular objects that here we tend to be looking at. But here we are going to be using the method or a method that is known as computation in terms of irregular areas. And here we are going to be borrowing a unique method compared to that one that we have been used before. When you look at the area that we have been used to find the area of a given irregular object, we have been looking at areas concerning water bodies, and for it we used to say that the area equals to full squares plus half squares. Then you divide them by 2. In other words, you divide the half by 2. But here things tend to be changing, and here we are going to be looking at the method below there, which says that AB times A times BC minus, in bracket, the AB times BC divided by 2 plus DE times EF divided by 2 plus GH times HI divided by 2 plus JK times KI, and then you look at divide it by 2 and then you put it in bracket. So that's how we usually tend to work out the formula of irregular objects. But here there is an illustration which tries to show it how it looks like. Now, when you look at point A down there and also point B, we are going to be looking at the distance from there up to there times B and C. In other words, that means that we are determining the length and the width. And here we tend to first look for the biggest shape or figures. Shape or size. If we have determined that when you look at point A, B, and BC being the biggest figures or the biggest size there or shape, we first have to find out their area. Are we together? Then you get the centimeters from A to B times B to C. That means that we have known now the area of the whole object or the big surface or the irregular surface. The next thing is we are going to be multiplying these inner squares or the smaller squares until where we shall be ending at FG, then KI, then JK. So that is one of the samples that you can use. If you have been having a map extract, that one you can clearly use it. And also if you have an irregular object that may be displayed on a graph sheet or paper, it can also be important. So that's how we work out the formula of those irregular objects. So in case you are given that map extract, all those square boxes in there, they are just equivalent to 2 units or 2 centimeters. So you obtain those 2 centimeters, then you look at how that irregular object runs within. From there you carry out, even you label them or you give them figures, for instance AB, CB. Then also you go in and substitute in the figures, then you find the area. And also here we tend to also borrow the idea of the GIS or the Geographical Information System. It can also clearly work out for you in there. Now, after calculating, we all know that if we are calculating area, automatically it will have to be giving us 0. It will be the figure that we get at the end should be in centimeters. When we move on, we are seeing that here they have tried to substitute in the figures. We have 26 meters squared. Then in map, they are saying squared times 50,000 ground. That's the actual ground. Then you come at the answer where they are saying now it is 6.5 kilometers. In other words, you also have even to convert that answer into what you call kilometers. Below there you have a assessment question or exercise. We say that using a topographical map of your choice, calculate the area of the feature on it using the scale provided. So sometimes even you may be given a scale, it may be of 50,000. Then they tell you that calculate the area. So where you see this, when you look above to this calculation, where you are seeing the 50,000, that was the area of the ground. So that means that you have to be substituting in the area of that ground. When we proceed, we are going to be looking at determining the density of features, distribution, and also degree of depression. So that is also another calculation we are going to be looking at there. When we proceed, we are going to be looking at the uses of the geographical positioning system, and we find out what are their uses. They are saying the determination of the feature location in the field and on the map manually can be problematically, or it can be a problem, but the technology has simplified this with different use of electronic devices. For instance, you can talk about the geographical positioning system that is much used there. So in other words, it can help to determine the location. It can also help in defining, locating in terms of direction. That is what we call the global positioning system, or what you can call the geographical positioning system. They are saying that this unit can be used to determine direction, distance traveled, and determine the routes of the travel in the field situation. It can actually try to find locations, distances, direction, and also the distance traveled. That is what we call the global or the geographical positioning system, how it operates there. In other words, once the information is obtained, the information is stored in what we call a software. Then it is transmitted directly to the satellites. Then the information is stored. From there, it is back onto the Earth's surface. Once a researcher or somebody wants to be finding out certain information. When we proceed, we are seeing one of the sport tracker known as the geographical positioning system. That one is there. We can see it and also look at it. Now below they are saying I have those some questions there. Can also help us to know our major task. Those are also one of the references that actually you can look out for in case you want to be finding out certain information concerning how you can be able to tell direction and distance with the help of the GPS. So next time we are going to be picking up there from what we call relief presentation, where we shall be looking at the conical hills, plateaus, valleys, ridges, and the cliffs, or what we can term as spar. I beg to submit.